Robert Lawlin, a Nobel laureate in physics, said that there's a field in technology that just won't work out. It's never to come, it's never going to exist. And on paper, he's not wrong. The technology, it's unstable. It's built off physics that doesn't work in our regular world. And he's not the only one. There's investors at big banks. There's award-winning physicists. There's people smarter than me who say that this technology won't work. And the worst part is, Mark Carney, he just invested $1.4 billion into this technology. So it's kind of a horror show. My name is Arian Hussaini, and this technology is called quantum computing. My role in it is a quantum key distribution researcher with hollow core fiber optics and entanglement protocols, with also protocols in BB84's state protocols. And I'm also a high schooler, which means that I'm not completely against quantum computing. In fact, it's my career. And I think I want to take this speech to just let you know where your tax money is going. And you might be wondering right now, well, Arian, what even is quantum computing? What did Mark Carney just do? And that's a good question. I'm sure you want to know where your $1.4 billion of tax money went into. So let me explain. Our regular computers use zeros and ones. They're like the alphabet of what our computers are like. And these are basically electrical signals. In quantum computing, they use qubits, very creative name, where a qubit can be a 0 or a 1 or both at the same time, and that's called quantum superposition. They can also be in an entanglement where two qubits can have the same properties, or we could amplify solutions with interference, whatever. This isn't a physics lecture. What really is important is that quantum computers can process a lot of data and really, really fast. What would take thousands of years on a classical computer would genuinely only take a few seconds on a quantum one. And you might be wondering, well, Arian, this is so cool. Well, the thing is that these work according to the laws of quantum mechanics, of quantum physics. We, as humans, follow the laws of classical physics. So when these two worlds interconnect, they don't really mesh well with each other. You see, quantum mechanics is very sensitive. Because these qubits can hold so much information, they're kind of like a bubble that's ready to pop. Even if they touch like some small little pin, they're just going to pop. They're losing all of that quantum information. So that's why these experts and investors are saying that it's not going to work. That's why we're spending billions of dollars to make this this technology work. And now you might be wondering, well, what's the point? I promise it's worth it. You see, these quantum computers can do really, really cool things. One of these things is that you can make them have unhackable properties. You can make computers and systems that can never be hacked. This means your banks, your institutions, your militaries, anything. If they adopt quantum computers, they can never, ever, ever be hacked. The second big thing is in biological applications, where these computers can be used to make life-saving drugs for deadly diseases. Crazy. And the third thing, and you might be a little bit scared, and it's also the field I work in, they can hack like every single computer, every single institution. This means your banks, TD, RBC gone. This means your institutions, your militaries. And before you check your phones to see I stole all of your money, I didn't yet. And you might be wondering, well, why not, Arian? Like, it's right there. You use your quantum computer. I'll get to that later. The fourth big application is that they can optimize systems perfectly. This means work scheduling. This means traffic routes. This means flight routes. And combined with AI, you can ask it any problem, and it will give you the most optimized, perfect solution. Arian, or a quantum computer, how do I solve climate change? Gone. Arian, why is there world hunger? Gone. Arian, why don't I have a girlfriend yet? I don't know if a quantum computer can solve that one, but it probably could. So these quantum computers can do really, really cool things. So why aren't we doing it yet? The thing is, the key word here is can. They have the potential, the capability of doing these really cool things. We just haven't made the computers yet, which is why I'm not taking your money right now. But beware. The fact is, these quantum computers are sensitive. These computers won't be able to make it into this real world until the turn of next decade or the next century. In fact, I don't know. The future is so unclear for these computers. But this field isn't just some small niche field with a few scientists working in it. No. Mark Carney just invested billions of dollars into this technology. There's scientists all over the world who are working on making quantum computers a part of our everyday lives. But these experts and these challenges and these different problems that we're facing, it's preventing us from actually making a quantum computer, from being clear about what the future looks like. And to why I'm making this speech. I'm not making this speech because of a physics lecture or because I'm telling you that I'm going to steal your money. I'm making this because of these scientists. These scientists have been told by experts and by their own journeys that this technology won't work at all. But they've kept persevering. Why? Because they know something that these experts don't. You can't tell the future based off of the problems of today. And it sounds obvious. You can't tell the future, but I really mean it. Just because today was difficult, just because we couldn't make a quantum computer today, doesn't mean that we're never going to be able to. Doesn't mean tomorrow is going to be as difficult either. You see, our future is so unclear. We don't know anything about it. And that's the beauty of it. That's the beauty of humanity. We're not able to find out what our future is, what the future is going to look like. You see, these quantum scientists, they're very, very smart. And not in the university, PhD, young Sheldon type of way. They're smart in the way that they don't know, or they know that they don't know everything. They don't know if this is going to be a billion-dollar waste of money. They don't know if a quantum computer is actually going to change the world, because it can. It can change our world. But they don't know. They don't know what the future looks like, but they know that if they don't try, the future won't be changed at all. So they keep persevering. They keep making computers and algorithms, and it's the biggest thing that I've learned working in this field. You see, when I started working in this field, it was difficult. It was these abstract, difficult ideas and problems, this complex algebra and math, and those weren't even the biggest things I've learned. The biggest thing I learned wasn't the quantum mechanics, wasn't the complex calculus, wasn't even the algorithms. The biggest thing I learned was the setbacks of the journey, the challenges of the first beginnings, the problems of square one. You see, when I started working in this field, I used to make papers, and I would publish these papers, and I present them to professors. And I remember this one time, I was in an online meeting, and I presented one of my publications to a professor in this meeting. He laughed straight in my face. He told me, "Arian, you're too young. What are you doing? It doesn't look like you can grasp this concept well. This publication isn't going to be able to make any increment. I don't know if you can make an increment in this big community. You know, it's filled with smart people. Why are you working in it?" And in that moment, it was difficult. It was difficult for me to keep persevering. It was so hard not to keep myself from crying on the spot and saying, "I'm sorry, I won't do it. I'll go into something else." And it was so easy for me to judge my future in this career based off what I was seeing in that present moment. But I kept going. Why? Because I remember my colleagues, these quantum scientists, they kept going. They kept making their papers, they kept making algorithms, and they kept making their computers because they looked into the face of these experts and said, even if you don't believe in my work, even if you don't believe in me, I believe in me. I believed in me. I believed in my impact. I believed in my work. I believed in my capability of changing the world. And that's led me to some great things. Now I can stand here and talk about quantum computing. Now I've made my own publications and my papers and these complex ideas, and it's paid off for me because I didn't judge my future based off of the difficulties of the beginning, of square one. Now, the reason I'm making this talk is because I believe our world has become so analytical. We ask our AI agents, "Be sure that I'll succeed. We want to get validation from others of, are you sure that this journey will end up in something fruitful? We try and make sure the destination is perfect before we even start the journey. We try and make sure that the end goal will be completely perfect in our own eyes before we even make it past the halfway point. And I'm here to tell you to stop. To stop. The future can't be determined, no matter how hard we try. Just because today's hard doesn't mean tomorrow will be. Just because there's problems right now doesn't mean that it'll end in a failure. Because we as humans just keep trying. We keep trying, and we're going to keep persevering because we look into the faces of the people who disagree with us, and we say, no, I'm going to keep trying. I'm going to keep doing this. I'm going to persevere. And I want you to do that. Those scientists looked into the face of investors and experts all over the world and said, even though you don't believe in me, even though there's challenges in the journey, even though that it's hard, I can do it. Because I know that this technology, that my work, that I will be able to change the world. The capability is there. And I want you to do the same thing, to look out into the world and say, even though you don't believe in me, even though today is hard, even though the future is more unclear than ever, I'm going to keep trying. I'm going to persevere. Not because I know it's going to work out, because the future is uncertain, but because I know I have the capability of making a change in the world. I'm going to keep trying because I'm human. I'm going to keep trying because I know I can make this quantum computer. I'm going to keep trying because I can, and I have the capability of making a change in this world. Thank you.